Okay, so as in the last video, we have started solving the self-check exercises from the federal book, alright, and we of course solved the first exercise, which was 1.1 self-check exercise, right? Let me give you a revision of that in a very short interval of time, right? NH3 is an important. I said that leave that part. If they are asking you this is important, this was the reactor, you don't have to do anything with the reactor, right? They have just given this balanced chemical equation and they have asked that how many moles of following are required. They have asked the moles of these two and they have given us the mole of this NH3, alright. This NH3 they have already given us the mole, right? So what we did here, as we were known about right, this 5 moles was the moles of this NH3, right? I need to have only one one molecule or one compound of NH3 moles, right? So I divided 5 by 2 and I got 2.5 moles. So 2.5 moles were the moles of one compound of NH3. So if there is 2.5 mole, so how many moles of N2 would be there? Of course, their stoichiometry coefficient is 1. So this 1 will be multiplied by the one compound of NH3 moles, and that is 2.5. Then we said here there are 3 stoichiometry coefficient, so 3 will be multiplied by the one compound of NH3 moles. So 2.5 into 3 has given us 7.5 moles. And here we completed our 1.1 self-check exercise. In the today's video, we are going to solve the exercise 1.2 or self-check exercise 1.2, right? Let's read the question and then make the data and solve the question, right? This is very easy, damn easy, no need to worry about anything. The main engines of the US space shuttle are powered by liquid hydrogen and liquid oxygen. Now see, this first equation isn't, or this first statement isn't important at all. It isn't necessary, right? It isn't significant. You can read this. This will not give you any information about what you need to find from the equation, what equation is being given. You won't get anything, right? The main engines of the US space shuttle are powered by liquid hydrogen and liquid oxygen. It is not giving us sense, it is not making sense, it is not meaningful. Now see the second statement. If 1.02 into 10 to the power 5 kg of liquid hydrogen means kg, means this is mass given, right? 1.02 into 10 to the power 5 kg of liquid hydrogen is carried on a particular launch. What mass of the liquid oxygen is necessary for all the hydrogen to burn? The equation for the reaction is, they have already given us the balanced chemical equation. 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water, right? So now they have given us the mass of the liquid hydrogen, means this mass we have already known, and that of course is equal to, wait, this is equal to 1.02 into 10 to the power 5 kg. Now see, if they have asked us in the gram, we need to convert that kilogram into gram first, right? Because we know that the standard unit which we calculate in is the gram, right? So but here the answer is given in the kilogram, means we don't need to convert this kilogram into gram. However, we need to put the same, we need to make it remain same kilogram, right? Mass of hydrogen is given, we need to find the mass of the oxygen. We need to find the mass of the oxygen, mass of oxygen, right, which is unknown. Now see, if the mass of one quantity is given, you can find the number of moles of it, right? What formula we have studied? We have basically studied 3 formulas for calculating the number of moles. The first one was given mass per molar mass, Second one was given volume per molar volume. Third formula was given particles upon Avogadro's number. Here which formula we're gonna apply is, see, the mass is given in the question and we know the molar mass of hydrogen as well, which means we can easily find the number of moles, right? So we're gonna apply here the first formula, which means number of moles is equal to given mass per molar mass, right? Given mass per molar mass. So now see, given mass per molar mass. Now you need to now you have already given mass in the question, right? You need to divide that by the molar mass. So now let's divide this given mass by the molar mass of it. So given mass, we know that it is 1.02 into 10 to the power 5, right? Upon molar mass of hydrogen, let's calculate that, right? 2H2, right? We know that 2 will be multiplied since there are 2 you know what, compounds, or you can say molecules of hydrogen. 1 into 2, so 2 2s are 4, right? Divided by 4. When we're going to divide this mass by the molar mass of this, we're going to get how much moles. The number of moles would be equal to 25500. That you can calculate by the help of calculator, right? So now we have got number of moles. Now you can easily find the mass of the oxygen, right? You can put this number of moles here in this equation and you can find that, right? So number of mole, again same formula, mole is equal to given mass upon molar mass, right? So given mass we don't know, we need to find that given mass, right? So now we know the number of mole. So let's put this number of mole here instead. 25500, right, is equal to, we are finding the given mass. So instead of given mass I can write X upon molar mass of O2 would be 32 gram, right? 16 plus 16 is 32. So 32 is dividing here, when it will go there will be multiplied. So X is equal to 25500 into 32. When you're gonna multiply this by the help of calculator, or you can do this by your hand as well, you're gonna get 816000, right? Of course kg2, since we have found in the kg, right? We have not found in the gram. So now we have point here, means there is not any point, means point is at the end. This has moved 1 2 3 4 5. We need to bring the point here, right? We need to bring the point here. So how many digits it has covered, this point? 1 2 3 4 5. This point has covered basically 5 digits. So I can easily write, right, 8.16 into how many digits it has covered? 10 power 5 kg, right? So let's check this answer. 8.616 into 10 to the power 5 kg. 8.16 into 10 to the power 5 kg. Means our answer is 100% right. What we did, we were basically given the mass of one substance, one reactant. By that we have found the number of moles, and that number of moles we have put here to find the given mass of another reactant, right? And that we have found as 8,16,000. And when we converted this to the scientific notation, we have got 8.16 into 10 to the power 5 kg, and here we have verified our answer as well, and of course that is correct, right? So till today we have covered two exercises, two self-check exercises, the 1.1 and the 1.2, and I have guys explained you, I have made you understand this. In the next video, we're gonna solve the self check exercise 1.3. This was all for today.